14 squared plus 9 squared. What is that? 14 squared plus 9 squared. Huh? I couldn't hear you talking real quiet. Okay, and do 18 squared. Is it the same thing? Okay, so if they're not equal, then is it a right triangle? No. No right triangle. No, it's not a right triangle. All right, Maggie leaves her home and travels 4 miles to the east. So let's say her home's right here. She travels 4 miles to the east. Which way is that? That way? Okay, so we'll put a 4 there. Then she travels 7 miles north. All right, and it says, and stops to pick up pizza. How many miles will she travel to return home if she takes the most direct route? The direct route between 2 points is a straight line, correct? Mm-hmm. So if she goes diagonally back home, we want to know how far that is. That looks like a hypotenuse to me, because if I go east and north, that's going to be a right triangle, correct? So how would I figure out what this hypotenuse is? Boy, y'all are awful quiet. How do we find out the hypotenuse of a right triangle?
7 squared plus 4 squared, and then find the square root.
So it's the square root of a squared plus b squared.
Yeah.
Which is what that is. So plug that into a calculator.
I just did it.
It's what?
65.
65?
Yeah.
Was there just 65 exact?
Yeah.
Okay. So equals 65. So that happened to be a nice whole number?
Square root of 65.
Oh, square root of 65. Okay. If we wanted to get this to like the nearest tenth, like they're saying, can we actually have that in square root form if we want to estimate to the nearest tenth? So we need to make sure our calculator is doing it in classic mode. So change your calculator to classic. So this is equal to 8.06. Keeps going. So nearest tenth, which would be 0, right? So we just say 8. So it's basically 8. So this is basically equal to 8. I'll just round the nearest whole number because, I mean, putting 8.0 is kind of stupid, right? Oh, I could put 8.1 then. Yeah, I forgot about that. I could put 8.1.
No. Why not?
Yeah, it doesn't really matter. To me, it doesn't really matter. If you get 8.1, that's still pretty close. I wouldn't be too worried about it. All right, but if we wanted to be more exact, we would say 8.1 tenths of a mile. Correct? All right. Any questions on this? All about the Pythagorean theorem. Some of y'all were a little slow on answering that. Looks like we forgot our beloved Pythagorean theorem. No love for the Pythagorean theorem. Really terrible. All right, let's pull up our exponential factor.
Alright, everyone take out your packets that we went over yesterday.
I'm not sure. I think this was not on there. So we can just go to the find where that is. No, don't do it like that. This one. Full mode.
Is it still?
Full mode. Next you go down to this. You can switch between
But
the
it's okay.
lines.
It's like something.
So I think this is something else.
Is it for cute as well? I don't like that. This is for the
That was only 6 pages. I put like a billion. I was like, wait a minute, I know I was working in the computer lab as well.
I think it's 18. I thought we was on my class.
Is that what you want to be right there?
Yeah.
I got you. Now you see this bar on the side over there? Look up there. That bar on the side over there on the left.
I went 2 hours.
Move it up and down. Don't touch it though, because it'll move that whole image. It'll move it around and it'll mess you up. So, but you can write on it just like that. So you're good to go.
So this part right here.
Yeah, and if you want to scroll down to see the rest of the page, then you write it. But when you want to scroll down.
this again since there was a field trip yesterday, and a lot of you guys were missing almost a third of the class. So, for those of you who were here yesterday, this is going to be a good review. And for those of you that weren't here, I'm going to go through this a little bit faster, but if you have questions, raise your hand, tell me to slow down, or if you don't understand it, tell me you don't understand it. Because this is pretty simple stuff, so I have a feeling going through it quicker, I think it's going to be okay. Alright, so we're talking about exponential functions. So before we even start the exponential functions, I'm going to go ahead and write the equation so you can see what it looks like. This is new for, I think there's like 5 of you. Okay, you see that the x is in the exponent? So before we did quadratics and it was like this, right? It was like in the, this is a little off. See how it was in the equation? Not in the exponent. So today we're doing exponential functions. We're learning about them. This is a concept. Okay, so that's going to make more sense when we go through this. So it says from the previous lessons, this is the first lesson, so we'll just ignore that part. Name 2 characteristics of exponential function. There's actually a couple more that I'm going to add in. So what's the first one that I just said? Yep, x is in the exponent. So go ahead and write it. X is in okay, you can just put a comma at one. And then another thing, the rate of change is not constant. That means when we did y equals mx plus b, wasn't the slope constant? So I'm going to just draw a little side graph over here. So this is going to look something like that, where it's not constant. So rate is not constant. Okay. Then I'm going to add some more in here. The function is always increasing or it's always decreasing. It's never the same. Okay? So just write always increasing or decreasing. Okay? And then the fourth one is it approaches a boundary line. And we're going to get more into that later, but go ahead and write it so we're just familiar with the terms. Approaches a boundary. So that should be written on the paper, okay? Does everyone have this copied down? Or I have to make it a little bit more time? I know the guys were here yesterday. Kathleen, do you have this down? Okay. Okay. So in this lesson, this is just telling you guys what you're going to learn in these notes today. So we're going to identify if it's exponential growth or decay. Okay? Another thing that we're going to do is we're going to identify growth factor. This is new terminology, so I'm going to show it to you. Growth factor rate. Okay? And we're also going to identify the initial value. Alright, if I'm going too fast, just tell me. Because I know most of you already have this down. So I'm going to leave that at the top so you can get it. Oh, actually, I have to go up more to get the graph up. Okay. Next one. Graph the following. So we're not going to do our input-output tables just yet. I'm just going to show you guys an example of what a growth exponential graph would look like. And then eventually a decay too. So first of all, who remembers, I'm going to write down what our initial value was from yesterday. This is going to be A. So you guys, I want you to just go ahead and write it. We're going to put it in our notes later. A equals initial value. And on here, with just this form, that's actually going to be, whoops, this is down here, not 1. Right here. This is A, okay? And then what's B?
Rate.
Look here, you can just see it. Yep. So here's B.
And if you think about it, when you're raising it to an exponent, that's why they call it an exponential function, right? what are you raising to an exponent? You're raising 2 to an exponent, correct? That means you're going to repeatedly double this. You're going to repeatedly multiply by 2, however many times that x is, correct? So if you think about it, the initial value, being a, is where you started before you actually did any multiplying. Then you're going to multiply by 2, by 2, by 2, by 5, whatever that exponent says. If that x was 3, then you would have 1 times 2 times 2 times 2. If that x was 4, times 2 times 2 times 2 times 2. But you always started at what? 1. Don't you think that that initial value is extremely important to the function? Because if I start higher, isn't it going to grow even quicker? Because I'm doubling something that's larger, correct? Does everybody understand? All right, so it's very important. And that's a little bit different than linear. Does anybody remember when we did linear function, what was actually the initial value? What part of that, when we said y equals mx plus b, right? What was actually the initial value? The plus b, wasn't it? The y-intercept. That's a little bit different, isn't it? It's a little bit different. It looks a little bit different. But it is important to know those differences. In linear, the plus b was the initial. But in exponential, the a out front, what you're actually multiplying is going to be what? Your initial value. Okay? That's why you keep seeing these words like rate and initial value. It's the same words over and over again, but different functions. So we really, really need to understand what they mean for each type of function. Okay, so we're not just giving you these for just fluff. You really need to know that.
Yeah. And if you weren't here yesterday, Harley, we're going over it right now. So if you weren't here yesterday, I'm going to explain all of this. Okay?
Yeah.
I don't mean to call you
Yeah,
out, but
just listen.
yeah. So we're going to fly through it, and then with the homework section, I'll let you guys work in pairs, and you guys can catch up. If you don't understand something, you can ask your partner or neighbor. Okay. So there is a way to graph this with an input-output table. We're going to go into that. So I'm just going to sketch what this would potentially look like. Okay. Do you see that from here over, it is raising up? That means what? Growth. Okay. That's pretty easy. And this is supposed to be at 1. It's off a little bit. So that also represents my intercept until we start adding and translating. But we're going to get into that later. So right now, I just want you to be able to look at a graph and say, that's growth. Because why? It's increasing. Okay? So that's just a simple sketch. That's not going to be exact. Yes.
Wait, I forgot what the 2 was. Like the b value.
Okay.
It's the b value. Yes. It's
the
the
B
rate.
value. It's the rate. And we're going to go through that again. Because remember we got into it yesterday? So we'll get there. Okay? This is just to catch up. We're trying to catch up the people that weren't here yesterday. So many people. Okay. We're gone. Okay. So same here. So what is my A value? 2. So it's going to cross right here. This value is bigger than 1, so that's how I knew that it was growth. My B value is bigger than 1, so that's how I knew it was growth. So if I was going to sketch this, I would actually sketch it like that, okay? Can you look at that and say, oh, that's positive, it's going up, it's growth. So on your guys' test or homework or anything that you're working on, if you have a graph, you just automatically know that's growth. What else do you automatically know just by looking at the graph? Okay, yeah, you can look at the y. You can see the y-intercept, which is your initial value, and then you can also tell just by it going up if this number, the b value, is bigger or less than 1. Because if it's less than 1, it's going to go down, it's going to decay, and if it's more than 1, it's going to be growth and it's going to go up.
Did you hear what you just said? You just said the initial value was the what? And in linear equation, what was the initial value? Might look different in the equation, the plus b versus the a, but it was still the what? It was still the y-intercept